Hello, my name is Isman Saputro. I am a student majoring in mechanical engineering at UNS, and I will present characteristic of the UAV structural design and platform in the military use environment, state and development. And this is the table of content. First, introduction. Second, development of UAV using additive manufacturing method. Third, strategy of UAV platform in operation. Fourth, effect of UAV component design, aerial performance, and last, conclusion. Evolution of unmanned aerial vehicle or UAV that started during World War II has come a long way for both military and non-military operation. UAV are finding widespread use in field where employing a human operator is either cumbersome and unsafe or not required altogether. Application and mission of UAV now range from agricultural surveillance. There are many industries where the drones can be found, from delivery drones to search and rescue, one which can be used for laser mapping, to military drones. There are many ways to improve UAV performance, which I will explain. First, development of UAV using additive manufacturing method. Introduction of AM. AM or additive manufacturing has not just revolutionized the field of UAVs, but has impacted the entire manufacturing arena by simplifying the design and easing the fabrication process. AM more than any other technology has served as the bridge between digital and physical disruption. There are slight difference in the manufacturing process using conventional method with the additive manufacturing method. These differences are shown in the following figure. As you can see, there is slight difference process at the development of UAV using additive manufacturing method, especially at the aftercare design. The conventional fabrication method, can it be fabricated? If yes, next to molding and tooling, fabrication and post-process. And the additive manufacturing method after CAD design, next to build strategy of superstructure, next fabrication, supersystem removal, and post-processing. And the following figure shows the development of additive manufacturing technologies and their application in UAV. Additive manufacturing milestone. First, at 1983, SLA was invented, and next to 1986, patent for SLS was filed. At 1988, FDM was invented, and at 2000, first injected 3D print was unveiled. And UAV fabrication using AM started from 2011 with Sulsa is first known fully 3D printed UAV, and most every year UAV using 3D printed was made. Next, on UAV, the reduction of structural mass is of primary importance to improve the payload mass and to reduce the fuel consumption and the gas emission. One way to reduce structural mass is to replace the milling process method with additive manufacturing for a spark gap fitting. The spark gap fitting is critical part responsible for the low discharge from the spark to the fuselage. In research conducted by Carl Giovanni Ferro, an existing path has been reviewed, changing the manufacturing technology to evolve if there was some sort of convenience both from structural and manufacturing point of view. It has been shown that milling process require 1.24 hours to manufacturing the part without considering the control and setup time. As we can see at the left or y-axis, this is time requires of process, and this is the method, which originally solid and lattice, which is 3D print. As you can see, 3D print have less time than the CNC process. And the study have also conducted to see the effect of 3D printing on wings considering optimal lightweight, alert, and low distribution. In the additive manufacturing industry, there are several types of infill that are used, as you can see here. And this, based on research conducted by Pavol, the results show that the most suitable pattern for printed wings is 3-hexagon pattern, which have less deformation than the other. At the same time, experiment has shown that for application require a high degree of elasticity, it is possible to use the pattern of cross 3D and gyroid. Next, safety of UAV platform in operation. UAV also needs good flight planning for safety purpose, especially if flying over mountain. Based on the perform and analysis, simulation after application of selected research method, it followed that the accuracy of UAV. The simulation carried out show that the ambient air temperature, which affects the thrust of the engine, also has a significant effect of the flight profile. Along with the decrease in engine thrust, the aerodynamic properties of the UAV, which were taken into account in the description of the kinetic member, changed dramatically. For the above reason, as well as reliability dynamic relationship between the UAV and its operator, it is important to choose the correct flight programming, which must take into account the response time of the UAV system in real time. Next, effect of UAV component design to aerial performance. For an aircraft that perform that kind of mission, maximizing the flight time and the range is of major importance. On the one hand, optimizing the lift-to-drag ratio, increase cruise range, and overall better performance, enhancing the overall aerodynamics efficiency of the ascents. One of the ways to improve UAV performance is to use winglet. The selection of the winglet design is very important to aerodynamics performance of the aircraft. There are several types of winglet that are often used. Several types of winglet were analyzed and compared, so I will find the type winglet that had the best aerodynamic performance. There are 5 configurations used in this research. By installing the optimization geometry on the plane, a formidable increase in lift-to-drag ratio has been achieved. Calculations show an increase in flight time equal to 1 hour or 10%, as we can see at the table here. Next, the empennage is in UAV is used the longitudinal and directional stability. In addition of the wing optimization of UAV design was also carried out on the tail or appendage. Empennage should be designed in such a way that it has to produce less drag at elevated angle of attack and good stability characteristic at steady flight condition and different maneuver condition. As in the research conducted by Regis, with research title design of optimization of SUAV empennage, compare the performance of 3 tail configuration, namely conventional, anhedral, and V-shape use analysis in ANSYS Fluent software. From the result, it is concluded that V-shape tail configuration give better performance than other 2 configuration. It is also concluded that V-shape tail is having favor coefficient drag at various velocity and at different angle of attack. We can see here at the table. Conclusion: the development of UAV is getting better, starting from design, structure, material, and mission security system. In terms of security, additive manufacturing technology has begun to develop. Additive manufacturing technology is proven to be more efficient than conventional technology that use CNC, both in terms of mass, cost, and flexibility. This advantage can provide the aerodynamic advantage of the UAV as well as the ease of production, but for a large scale, additive manufacturing technology is still inferior to the CNC method because it takes a long time. From the research conducted, it can also be concluded that the use of the 3-hexagon pattern is the best choice for the wings. In missions that require UAV to fly near mountains, the correct calculation has also been found, namely using a normal force control and rotation control algorithm to maintain safe UAV altitude when conducting mission near mountain. Various studies have also been carried out to optimize the UAV design. This is done to find the best design that can be used according to mission requirement, one of which is the addition of a winglet on the wing. The addition of winglet has been shown to increase the aerodynamic efficiency of UAV. The research was also conducted to compare several tailing of UAV to find the best choice for the UAV application. This research compared conventional tail, unheaded tail, and V-shaped tail. V-shaped tail is proven to have the best aerodynamic efficiency value. That's all from me, and thank you.